Good afternoon, guys. I'm recording this to put it on the internet for y'all. The homework is on page 278. Problems numbers 1, 2, 4, 6, 7, 9, 10, 14, and 15. Most of them are proofs. You need to be working the proofs, y'all. You need to be drawing the picture and putting down the information. Because the test that I have scheduled for next Friday a week, there are a lot of proofs on it. Yesterday we went over the ways to prove triangles were congruent. There are 5 ways to do that. Yesterday we went over side, 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 where you had to have 3 sides that were congruent. And we also went over side, angle, side, where you had a side, an angle, and a side. So the angle was included in the 2 sides. So that's what we did yesterday. So today we're going over 3 more. The first one is angle, side, angle. In which case you have 2 angles and an included side. So you have to have 2 angles and the side has to be between those 2 angles. So that's the next one. So 2 angles and an included side of one triangle must be congruent to 2 angles and an included side of another triangle. The next one is angle side, where you have 2 angles and a side that is not included. So you have 2 angles and a side that's not between the 2 angles. So 2 angles and a non-included side of one triangle must be congruent to 2 angles and the side of the other triangle. The last one is hypotenuse leg. In order for you to use this, you have to have a right angle to begin with. And you have to have a hypotenuse. So hypotenuse is opposite the right angle. So if you stand on the right angle and walk across, you're at the hypotenuse. So you have to have a right angle, a hypotenuse, and another leg. So if you have the hypotenuse and another leg, you can use HL or hypotenuse leg. So the first one I have, once again, is angle, side, angle, where the side is included or between the 2 angles. So the picture I have up here are 2 triangles. So in these 2 triangles, if we have an angle, a side, and an angle, we'd have to have an angle, a side, and an angle. So when you were going about proving something like this, you would have angle R is congruent to angle C. You would have side TR is congruent to side. Well, I started with T, so I've got to start with HC. And you would have angle T was congruent to angle H. So then, because you have a side, an angle, and a side, angle, side, angle, because you have an angle, a side, and an angle, we could say triangle RTW was congruent to triangle. I started with R, so I've got to start with CHG. Okay? So the next one is angle, angle, side, where you have 2 angles and a side that is not included. So if 2 angles and a non-included side are congruent to the corresponding angles and sides of a second triangle, then the two triangles are congruent. So up here, I have two triangles. So if it's angle, angle, side, then the side is not between the two angles. So in this case, we have Q is congruent to O, and angle R is congruent to angle M. And then RS, side RS, is congruent to side MN. So once again, you have an angle, and a side. So we will be using that for our reason that the two triangles are congruent. Okay. Next, we have hypotenuse leg. So if the hypotenuse of one right triangle and a leg are congruent to the hypotenuse and the corresponding leg of another right triangle, then the triangles are congruent. So the first question you should ask yourself when you're looking to use this is, do you have a right triangle? Yes. Do you have the hypotenuse? Well, stand on the right angle and walk across. Do you have the hypotenuse? And if you do, then you've got to have a leg. So if you have a leg, you could use hypotenuse leg. If you don't have a right triangle, then you can't use hypotenuse leg. And if you don't have the hypotenuse, you can't use hypotenuse leg. And you don't have a leg. So pay close attention to what you have. All right. So I have a number of proofs, and so I'll wait till you can get this picture on your paper. It shouldn't take you but a minute. So if you're given information, mark it on your paper or on your figure so that you can see what you have. It says QS bisects angle PQR. So what does that mean? That means that this angle is equal to that angle, and we decided this morning we were going to make it easy and label them angles 1 and 2. That's the information you have from QS as a bisector of angle PQR. We also have that PSQ, this angle, is congruent to RSQ. We're going to call this angle 3 and 4. You don't have to label them with the letters. The numbers. I just thought it made it easier when we were writing our proof. Well, the first thing we wrote down was that QS bisects PQR. So that was given. But what do we get from that information? What do we get? Angle 1 is congruent to angle 2. Definition of angle bisector. Hopefully y'all are writing this down and not just watching me do it. Alright, so the next statement we wrote down was that angle PSQ was congruent to angle RSQ. Once again, that information is given. So it's given. you go back and look at our picture, you see where these two triangles are stuck together. So what side do they have in common?
Q and S. Wait.
SQ.
What side?
SQ.
SQ. Good. So they have that side in common. So we're going to say SQ is congruent to SQ, and what would be the reason? Say that again. The reflexive property, yes, correct. All right. So if you go back and see what we have an angle, and a side. The question is, we wrote it down that way, but what do we have up here? We have an angle, a side, and an angle. So we're using angle, side, angle to say that those are triangles. PQS is congruent to triangle RQS. Okay? So don't just look at the information you wrote down, but look at the information on the picture, because that is more helpful. Because like I said, if you point to it, you have an angle, a side, and an angle, you're more apt to get it right. Okay? Everybody good on that one?
Can you go back down?
Mm-hmm. Good, Maddie?
This one.
Okay, so the next one that I have, I'll wait for y'all to get this on your paper. These triangles are also stuck together. Based on the information, they told you that angle K was congruent to angle M. So I marked that. JK is congruent to JM. So this piece is congruent to that piece. And JL bisects KLM. So that means this angle is equal to that angle. So we're going to name these 1 and 2. We'll name this 3 and 4. It also told you, or you can see that JL is congruent to JL, but I don't know that we need that information. So we said that KM was congruent to that angle K was congruent to angle M. That was given. We said that JK was congruent to JM. That was also given. We said that JL bisects angle KLM. That's given. From this information, we got that angle 1 is congruent to angle 2 as a definition of angle bisector. We go back and look at what we have. We have an angle, well, I'll start here. Angle, an angle, and a side. So angle, angle, side. So triangle JKL is congruent to triangle JML by angle, angle, side. Everybody good to go? All right. Okay, so the next thing I wanted to do is to go over the worksheet that I gave you. Everybody got it? Anybody not have that worksheet? All right, so it says state whether each pair of triangles is congruent by side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg. If none of those apply, then you're just going to write in or not possible. Okay, so the first question you should ask yourself on number 1 is it a right triangle?
Yes.
Yes. Do you have a hypotenuse? No. Stand on the right angle and walk across. Do you have this angle right here, this side right here? No. Do you have that side? No. Our hypotenuse leg is out. We can't use that. Do we have 3 sides?
Yes.
Do we have 3 sides that are marked? No. All right. What do we have? We have a side, an angle, and a side. So we have side, angle, side. Number 2. Thank you. Side, side, side. We've got 3 sides. Go side, side, side.
Angle, side, angle.
The number 3. Look at that carefully. What's wrong with it?
They have 2 different sides marked.
One is the base is marked and not
All right. Well, this side is between these angles, right?
the right.
That side's not between these 2 angles, is it? So this is a not possible or a no. Okay. All right. So, gotta go to the next page. All right. So, on these, which number 6 is on the page here. All right. So what do you know about these angles?
Vertical.
What do you know about vertical angles?
Congruent.
They're congruent. So vertical angles are congruent. All right. So we have an angle, and a side. Angle, angle, side. What do we know about this side?
Bisect.
No, it doesn't bisect it. No, we know that that side is in both of those triangles, don't we?
Yeah.
All right, so we have an angle, a side, and an angle. So we have an angle, a side, and an angle. So on number 6, do we have a right angle? Yes.
Yes.
Do we have a hypotenuse?
No.
No. We don't have a hypotenuse. But do we have a side that's common to both of them? Yes.
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 So we have an angle, and a side. So angle, angle, side again. Everybody good on those? So on the next ones, I'll give y'all a minute to do these. I'll
We already done 7, 8, 9. Wait a minute.
Aren't we on 10, 11, and 12? Hang on. Thank you, Lyle. All right, we'll give y'all a minute to do these. So what kind of angles are these? We know that vertical angles are congruent. So what did y'all say for this? Side, angle, side. What did you say for this one? Side, angle, side again. And this one?
Side, side, side.
Side, side, side. Good job. All right, everybody good on those? All right, so I'll give you all a minute on these. So on number 10, do you have a hypotenuse? No. You do not have a hypotenuse, so you can't use hypotenuse leg, but you do have an angle, a side, and an angle. So an angle, a side, and an angle. Number 11, do you have a right triangle? You have the hypotenuse? Yes. Do you have a leg? Yes. This is a hypotenuse leg. Number 12, you got vertical angles that are congruent, and you have a side, an angle, and a side. So side, angle, side again. Any question about those? So on these, what do we have? On number 13, do you have a right triangle? Yes. Do you have a hypotenuse?
Yes.
Yes. Do you have a leg?
Yes.
Yes. So hypotenuse leg. Because you have the hypotenuse and you have a leg. So what do you have here, Dan? Side, angle, side.
Side and side. Like,
Well, your choices are side, 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 hypotenuse leg, angle, angle, side, side, angle, side, and angle, side, angle.
Side angle,
Side, side, angle. Is that one of them? No. All right. So the next thing I would like to do is get out your homework from last night. And I'm starting with number 6. Yeah, why didn't you come for help? Y'all, if you're not writing down the examples that I'm giving you and coming for help, you're going to have a hard time with it. So if you didn't do this one last night, draw the picture on your piece of paper, write the statement and the reason, write the given information down, and what you're trying to prove, because I'm getting ready to do it. they marked the given information on the picture, so that was nice. So AB is congruent to ED. Every person in here can write down the given information on the paper. They can also write down what you're trying to prove. Now, you might not have the order right, but down here somewhere you got ABC is congruent to EDC. There's nobody in here that can't do that. And then they have CA is congruent to CE. Okay, that information was given. And it's also marked on your your picture up there. It then says that AC bisects BD. That's given. So what does that mean? It says AC bisects BD. So that means that C is a midpoint, right? So it also means that BC is congruent to DC. Definition of segment bisector. So if that is true, we should mark it on here. So we can say that triangle ABC is congruent to triangle EDC because of what?
Side.
Side. Right. All right. Now the next one, number 7, was a little bit more difficult just because it gave you all the information in the word problem. So you had to kind of pick it out. And I don't know if I can't move this. Let's see if I can make it smaller. There we go. All right. So in the word problem, we have some information they told you. They said the bridge, cable stayed bridge spans 4.1 miles of Tampa Bay. It is supported using steel cables suspended from 2 concrete supports. If the supports are the same height, so that's a support, and this is a support. So AB is congruent to ED, and that's given. They gave it to you in the problem. All right. So above the roadway and perpendicular to the roadway. So that means this forms a right angle and that forms a right angle. So we're told that AB is perpendicular to BD and ED is perpendicular to BD. That's given. From that information, we know that angle B is congruent to angle D. All right angles congruent. It goes on to say the topmost cables meet at a point midway between the supports. Number 4. C is a midpoint. Given. So if C is a midpoint, what do you know about BC and DC? They're congruent. Definition of midpoint. Or probably midpoint theorem would be a better answer, but nevertheless. So that means that this piece is equal to that piece. So from there, what can we say? We can say triangle ABC is congruent to triangle. We started with A, we're going to say EDC. And what's the reason, guys? Side angle side. Thank you. Number 13. Check to see if you're getting these right. Number 13 says R is a midpoint of QS and PT. Given. So if R is a midpoint from Q to S, then this piece is equal to that piece, and this piece is equal to that piece. So from that information, we get that PR is congruent to TR. Once again, definition of midpoint. Okay. All right, before I do the other piece, let's talk about this angle and that angle, which we're going to call angles 1 and 2. What do you know about angle 1 and angle 2? They're congruent. Why are they congruent? What kind of angles are they?
Vertical.
The vertical angles congruent. All right. Then we're going to say QR is congruent to TR. And the reason is definition of midpoint again. So how can we say that triangle PRQ is congruent to triangle TRS? Side angle side. Okay. Because we've got this side, this angle, and this side. All right, the next two couple of problems are similar to what you did on that worksheet, okay, where you're asked, make it smaller again. So you can determine, well, the first one's easy. What is it? Side, side, side. Because we have all the sides. What about the next one? Do you have enough information?
No.
No. Not possible. Because we don't have enough information. What about this one?
Not possible.
Why?
Angle side side or side side angle.
Well, there's not one for side side angle, is there?
So not possible.
So it's not possible either. Whoever said that in the back, thank you. All right. What is this? Angle, sorry, side, angle, side. Side, angle, side. Everybody good? Jane? Leave your cell phone. All right. So the last two are just problems that you're setting these up. All right. So we know that this is a right angle. So we know that 20y plus 10 equals how much? 90. So 20y equal 80. So y is equal to 4. If y is equal to 4, we can plug 4 back in here get that piece, which is 12 plus 7 or 19. So this side was 19 and this side is 19. Okay. I took 4 and plugged it in there. Okay, you can get 12 plus 7, 19. All right, and the last one you had looked like this. On this particular one, they told you that ABC was congruent to FGH. So I noticed that these were all sides, so I wrote down the sides. So AB, which is 13, is congruent to FG. So 13 is equal to FG, which is 4x plus 1. So I get 12 is equal to 4x, so x was equal to 3. Now because these are all x's, if you wanted to find the rest, you would just plug them in. So if you plugged in 3, this is 13. This gives you 9 minus 2, or 7. And of course, if you plugged in 3 here, you get 11. Okay. Now, if they were not all equal to x, maybe some were y's, then you'd have to set those up. Everybody understand that? Okay, so that was pretty much all the homework exercises, or all the exercises that we went over. I had some people ask questions on the homework from from tonight, but I'd rather wait and go over that tomorrow. Hang on, I was looking for, alright, well, that's it.